Welcome back to my chemistry channel. Lecture on thermodynamics. In this video, I'm going to discuss about enthalpy change. We can give the symbol for this enthalpy change is delta H. As you know that during chemical reactions, during chemical reactions, there is change in energy. Particularly, we can write heat energy. That is a change in energy, heat energy during the course of the chemical reaction. So when this change in the energy, heat energy at constant pressure, which is said to be 1 bar pressure, the change in energy is said to be enthalpy change. Enthalpy change, we say. So during the course of the chemical reaction, there could be change in energy, particularly heat energy at constant pressure. So then it is said to be enthalpy change. So which is indicated with the delta H we can write. Now, this energy may be absorbed, the change in energy may be absorbed or released. If the energy change is absorbed for conversion of reactants into the products, then it is said to be plus Q. If the energy is released, change in energy is released, the system is lost energy minus Q we can indicate. As you know that the Q is equal to QV is equal to then C heat capacity at constant value, and delta T is the temperature difference, which is equal to change in internal energy we say. If the QP is equal to CV heat, so heat capacity at constant pressure multiplied with the delta T temperature difference is said to be delta H. We can write enthalpy change. That means energy change of the system, of the system during the course of the chemical reaction. System here assumed to be reaction mixture or reactants. So that energy change during the chemical reaction at constant pressure is said to be enthalpy change. Already you know this equation, which is related with the heat capacity of the substance. As you know that enthalpy change is the state function. Enthalpy change also state function, which depends upon initial state to the final state. But in chemical reaction, what is initial state? Initial state is said to be reactants are the initial states, and the products, transformation of the reactants into the products. Reactants are said to be initial state, and the products is said to be final state, transformation. During the change of the reactants into the products, there could be change in energy. As you know that energy change or energy difference between the reactants and products is the cost for the chemical reaction, thermodynamically. And during beginning of the reaction or before starting of the chemical reaction, reactants have so delta H enthalpy. They have some amount of enthalpy that is said to be, so some of the enthalpies of reactants is said to be, so enthalpy of reactants we say. So this will be some value. After the chemical reactions, enthalpy change of the products, so will be having some value. Now, during this chemical reaction, what will be the enthalpy change? So it can be taken as in the name of enthalpy of reaction, enthalpy change of the reaction we say. Then how you define this enthalpy of reaction? So enthalpy of reaction is said to be enthalpy delta RH is equal to sum of the enthalpies of changes of the react products minus sum of the enthalpies of changes of the reactants. That difference only what we can get is the enthalpy of reaction we say. So during the course of the chemical reaction, we can get so enthalpy change of the delta RH. Enthalpy change of the reaction is equal to, so sigma B is the coefficient. So enthalpy change of the products minus, so sigma A enthalpy change of the reactants. The difference only what we call means enthalpy change of the reaction, we can say. So if this enthalpy change is observed, it is observed under set of standard conditions, then it is to be standard enthalpy change of reaction. What are the standard conditions? The standard conditions are 298 Kelvin temperature and 1 bar pressure, constant pressure is 1 bar, 298 Kelvin or 25 degrees Celsius temperature or 298 temperature. Then it is said to be what we call standard enthalpy change of reaction, we say. The standard enthalpy change of the reaction can be written as, so delta RH naught is equal to sigma. Sigma indicate summation, sum of the enthalpy change. B indicate coefficient, stoichiometric coefficient of value of the chemical reaction. So delta H products difference enthalpy change of the products minus, so sigma A is the coefficient, so delta H enthalpy change of reactants we can say here. So standard values of the products we should consider here. Standard enthalpy changes of the products we should consider. So that the difference between the standard enthalpies formation of products minus standard enthalpy formation of the reactants is said to be the standard enthalpy of a reaction, we say. At 298 Kelvin, so 1 bar pressure, so standard enthalpy of reaction can be calculated. So let's just consider example. So example of this enthalpy of reaction. There is one chemical reaction. So H2 gas, hydrogen gas, combine with the Br2 gas, bromine gas, to form HBr2HBr gas. HBr formation. This is the chemical reaction. So during the chemical reaction, so HBr is a product is formed from hydrogen and bromine gas when they combine. So during the formation of HBr, so then delta R H naught standard enthalpy of reaction is equal to, so sigma B is the coefficient delta H products minus A delta H enthalpy change of reactants formation. So here is delta H value of reaction will be minus 178 kilojoules per mole. Minus sign indicate energy is released. Energy is released during this chemical reaction, which is said to be delta HR, standard enthalpy of reaction for this HBr formation is, which is indicating exothermic reaction. This is indicating exothermic reaction. Exothermic change, we say enthalpy change is said to be exothermic, we can write. So here, and if you want to get, so enthalpy formation of the products and enthalpy formation of the reactants, then we must know the, so the enthalpy, standard enthalpy of formation of products and standard enthalpy, so of reactants from the products. Then we should consider the standard enthalpies of reactants. So, but here the standard enthalpy formation of the products from their elements. So here the standard enthalpy formation of the elements at 298 means at specific temperature, at 1 bar pressure. So if the element exists in stable form or pure form, see one element so will be existing in the nature stable and a pure form at specific temperature. For example, so alcohol at room temperature, alcohol will be pure at room temperature 298 Kelvin temperature, pure form. So that is the standard enthalpy formation of alcohol, pure form we say. And so standard enthalpy formation of elements in the pure form is equal to 0. Standard enthalpy formation, so of elements will be 0. Standard enthalpy formation of elements in stable form. So stable form, it is indicate with the 0. For example, standard enthalpy formation of graphite. So graphite will be 0, and bromine elemental form is equal to standard enthalpy formation will be 0. We can consider. Means the standard enthalpy formation of elements in a pure form will be, so standard enthalpy formation of elements will be 0. We can consider at the specific temperature of that particular element. For example, the standard enthalpy formation of iron. So iron will be in solid form at 500 Kelvin will be 0. We can consider. So in this lecture, I would like to introduce one more important concept is, so standard enthalpy of formation. Standard enthalpy of formation. So standard enthalpy of formation, we must know to get standard enthalpy of reaction. Sometimes we can write like this also: standard enthalpy of reaction is equal to 2 into standard enthalpy of formation. What is the standard enthalpy of formation means? So in a chemical reaction, for the formation of 1 mole, for the formation of 1 mole of the product, 1 mole of the compound or any product, 1 mole of the product. So for the formation of 1 mole of the product from its pure standard states of elements, So during this enthalpy change is said to be, enthalpy of formation of the product. If it is measured at 1 bar, if it is measured at specific temperature or standard conditions, then we can write the standard enthalpy of formation. Standard enthalpy of formation considered for 1 mole formation of the product from its pure elements. So let us consider one example for this standard enthalpy formation. Same example I would like to give. So H2 gas combined with the Br2 gas to form 2HBr is said to be, so delta RH standard enthalpy of reaction equal to minus 178 kilojoules per mole. This is, now if you see the stoichiometric coefficient, 1 mole of hydrogen gas combined with 1 mole of bromine gas to form 2 moles of HBr. 2 moles of HBr. So here HBr, the product is derived from the reactants, the pure states of the elements of the reactants. So 2 moles is formed. Now we can write this equation: 1/2 quantity of hydrogen gas combined with 1/2 quantity of bromine gas to form 1 mole of HBr gas. Then delta formation, enthalpy change of the enthalpy means enthalpy change of the HBr is standard enthalpy of this HBr is equal to, so it can be energy can be enthalpy of the reaction can be divided by 2, 178 divided by 2. So 2, 8, so 9 approximately. So minus 89 kilojoules per mole we can get. Now the enthalpy of formation of the product HBr equivalent to 1 by 2 of the enthalpy of the reaction. Then it is said to be enthalpy change for the formation of HBr with respect to 1 mole. One mole we can consider. Similarly, standard enthalpy formation of H2O, if you write, so H2 combined with O2 gives rise to H2O. 2H2O here is half and half H2O, and this is here also half H2O. Let me take, yes. For the formation of water, hydrogen combined with oxygen to form 2H2O. 2H2O, this is the balanced equation. Now, if I take H2 1 mole and half O2, so to form H2O, for this delta formation of standard enthalpy formation of this water is minus 285 kilojoules per mole per enthalpy formation of water. So enthalpy formation is considered for formation of energy change for the formation of 1 mole of product. 1 mole of the product. So the energy change, 1 mole of the product of H2O from its pure elements. What are the pure elements? So hydrogen and oxygen. During this energy change will happen minus 285 kilojoules per mole. This is said to be enthalpy formation of the water, standard enthalpy formation of the water. So minus 285. That means this reaction is said to be exothermic. Exothermic reaction, we say. So not only during the chemical reaction, so enthalpy change takes place during the physical process also. Enthalpy change takes place during the physical process. And what are the physical changes that takes place? For example, so water subjected to sublimation, the water subjected to fusion, the water subjected to evaporation or vaporization, we say. By supplying energy or by releasing energy, the physical changes also takes place during the physical change and the chemical change. Now, for example, if I take, so if the uh, phase transition or if the state of the compound, state of the substance changes from solid to liquid to gas. If the solid changes into the liquid, then delta F fusion enthalpy change during the fusion. The liquid changes into the gas, so delta V vaporization enthalpy change, we say. And if these energy changes are measured in terms of or in the conditions like 298 Kelvin or 1 bar pressure, then it is said to be standard enthalpy of fusion and the standard enthalpy of vaporization. Or if the solid change directly takes place to the gas, then sublimation enthalpy change, standard enthalpy change of sublimation, we can write. So now, for example, if I take water in the form of solid, which will transform into water into the liquid, then standard enthalpy of fusion will be equal to, so how much? Plus 6 kilojoules per mole we can consider, which is said to be melting. That means, so for 1 mole, 6 kilojoules energy if you supply for this, so water, then water changes into the liquid. Similarly, if you take the water in the form of liquid, 1 mole if you take, and if you want to change it to vapor H2O gas, so then enthalpy of vaporization is standard enthalpy of vaporization is equal to 40.7 kilojoules per mole. And if you want to make the changes solid to gas, which is said to be sublimation directly, if you want to do so, sublimation, and which is equal to enthalpy of sublimation, enthalpy change of the sublimation is equal to standard enthalpy of sublimation is equal to enthalpy of fusion, enthalpy change of the fusion plus enthalpy change of the vaporization, standard enthalpy. Some of these enthalpy changes of fusion and vaporization is equal to, so standard enthalpy of sublimation of the water. So that means here what we understand, so change of the state of the compound like water is said to be endothermic. Energy is absorbed. Energy is absorbed. Energy is absorbed during these physical changes. During these physical changes. So finally, what we understand, so during the physical process and chemical process, so there could be change in terms of energy absorption or releasing will takes place, and that energy change, if it is measured at constant pressure, is said to be enthalpy change, we can write. Thank you.